Welcome back to geometry. Let's finish off section 18.3. We've already done surface area of pyramids. Now it's surface area of cones. So let's check out our warm-up here. Emily is designing a terrarium for a contest at school as shown. The terrarium has a base that is a rectangular prism, the top that is a square pyramid. What is our surface area? So if we look at this shape, the bottom is going to be a square. And then we have 4 sides, and each side will be a rectangle. And then on the top, we've got 4 triangles. So let's just do these one at a time. The base is a square. That's a 5 by 5 square. Plus, we have 4 rectangular sides. Each side has a base of 5 and a height of 2. So that's going to be 5 times 2. And then we've got 4 triangles on top. Let me switch to black ink. 4 triangles on top, and each triangle is 1/2 times base. The base will also be a 5, times the height, and the height is given right here as 6. 5 times 5 is 25. 2 times 5 is 10, and we multiply that by 4 and get 40. And then half of 4 is 2. 2 times 5 is 10. 10 times 6 is 60. These two add up to 100, and then we add 25 more. So our answer is 125. Our units are inches, and it'll be squared because we're talking area. All right, let's get into today's stuff. A right cone is a cone whose axis is perpendicular to the base. The slant height L is the length from the base to the vertex along a lateral edge. So our base is going to be a circle, and then right above the center of that circle will be our vertex, and we'll connect it down like this. So this would be the height of the cone, and the slant height L goes from the base to the vertex. So this edge here would be L, and of course we would have a radius here at the bottom. Now this is a hands-on activity. We could do this in class. You're not going to obviously do it since you're watching the video, but I'll sort of walk you through it. We could use a compass on a piece of paper and draw a circle, and we would cut out the circle. And then we would pick a sector. I'd do like maybe a quarter of the circle, and we would cut this out. So when we have something like this, we could then take these straight edges, pull this straight edge over to this straight edge, and I'm going to sort of try to draw that. That would turn this into a cone. Let's say that the straight edges, these blue straight edges here, turned into this red line where they connected. So we might be able to see there that this radius is also the same as this L, or the lateral slant height of this cone. So using your circle cutter, where does the slant height come from? Slant height equals radius. The radius of the circle is the slant height of our cone. Now here it says part 4, watch the video and follow along. There's a 3.5-minute video that we found on YouTube that shows how to turn a flat shape like this into the cone and come up with the area. I will put a link to that video in the description of this video here on YouTube. But what we're going to come up with here, let me get rid of this. So if we have a cone, the base of the cone is just a circle, so that's going to be pi r squared. And then the area of that cone is going to be pi times r times the slant height L. So if I draw a little bit better picture here, of course this r is going to be the radius. L will be coming down the side of the cone here, so pi times r times L is going to be our slant height, or our area of that part of the cone. So pi r squared is our base, pi r L are the sides of that cone. All right, little fill in the blank here. The lateral area of a cone with radius r and slant height L is pi r L. Remember, lateral area just does not include the base, so we don't have to worry about the pi r squared there. the surface area of a right cone with lateral area L and, and base area B. So here they just turned all of the lateral area into L, all of the base area into B. So the surface area of the cone would just be L plus B. Or we could take out the L and replace it with pi RL, and take out the B and replace it with pi R squared. So this is the more useful one. This is the one we'll be using in the examples and the practice problem and the homework. Surface area is the area of a circle, pi R squared, plus our pi RL. So let's try this out on a couple of easy examples here in example 1, A and B. So for the first one, we need R. R is the radius, and we were given diameter. So let's cut that in half. Our radius is 7 feet. And here they gave us our L. L is 16. So since the formula is new, I'm just going to write it out here again in all its glory. Pi R squared plus pi RL. Well, pi is just pi. And our radius is 7, so that's going to be a 7 squared. And then we're going to add pi times R. R again is 7. And L is 16. So 7 squared, that's 49, and we multiply it by pi. 7 times 16 is 112, and we're going to multiply that by pi. And we're going to add those together and get our surface area is 161 pi. Our units would be feet and squared. Notice here in the directions it does say leave your answer in terms of pi. So there's our answer in terms of pi, 161 pi feet squared. All right, letter B, a little different. Here they didn't give us the diameter, they just handed us the radius, that's 10. But this is not our L, that's the height of the cone. What we need is this edge I'm hitting in blue ink. That's the hypotenuse of a right triangle. So I'm going to switch to red ink and come down here and set up a little Pythagoras. 10 squared plus 24 squared equals c squared. 10 squared is 100. 24 squared is 576. That's c squared. And if we add that up, we get 676 is c squared. And when I hit the square root button on my calculator, it come out nice and clean, 26. L is 26. So we can plug these into our new formula. Surface area, I like to start with the circle, pi r squared, so that'll be a 10 squared. And then we're going to add pi times r, 10, times L, 26. So if I square the 10, I get 100. There's 100 pi's. Plus 10 times 26 is 260 pi. And if I add those together, I get 360 pi. And our units are now centimeters, and we'll square them because it's area. All right, what's next? Suppose a mooring buoy, shown in the diagram, is attached to an anchor and it's pulled underwater by a chain malfunction. While it's underwater, the buoy collected 1 million algae cells on its surface. What is the approximate population density of the algae on the buoy? Well, let's look at our buoy. I'm going to color code. Here on the left side, we have a cone. L is 32, and the radius would be the same as this cylinder radius, 12 inches. So in red, we're going to have pi RL. Notice the circle here that would be the base of the cone is not part of the surface area because it's attached to the cylinder. So we don't need the base of that cone. Now I'm going to switch to black ink. Here we have a cylinder in the middle, a right cylinder. Once again, we can ignore the top and the bottom, so we just need the lateral surface area of that cylinder, and that's going to be circumference 2 pi r multiplied by the height or the length of that cylinder, and that's going to be 15 when we go to plug it in. And I'm going to switch to blue ink. And the other side of the buoy here is another cone. Base of the cone is part of the cylinder, so we don't have to count it. So this is going to be another pi times r times L. All right, let's start plugging in our numbers. Here in the red area, I've got pi. The radius is the same radius as the cylinder, 12. And we're going to multiply that by the L for the red part, 32. Plus, now we go to the cylinder in the middle, 2 times pi. Radius is again 12. Height here is going to be 15. Plus, now the stuff in blue, we've got pi. Radius is still 12. And the lateral edge here, L, is 26. So let's start multiplying here. 12 and 32, that multiplies to 384 times pi. And then we've got our 2 times pi times 12 times 15. The calculator tells me that's going to be about 360 pi. 360 pi. And then finally the stuff in blue, pi times 12 times 26. That's 312 pi. So everything's in terms of pi. Let's add those all up. Our total surface area is 1,056 pies. Now, if you're excited and you stop there, remember, we're not done. We wanted the population density of algae on that surface area. So I underlined it up here. It is in red. We have 1 million algae cells. 1 million cells. And we're going to divide our total population by 1,056 pi inches squared. So when we do that division, calculator tells me it is approximately 301.4. Remember, our units will be numerator units per denominator units. So that is 301.4 cells per inch squared. There we go. There's our population density. Now in the last one, kind of an odd picture here, but it says a crayon can be modeled by rotating a two-dimensional shape about an axis. So imagine here, what I'm hitting in black ink, that's going to be the axis that we are going to rotate around. So down here at the bottom, this little 4 millimeter, when we rotate, that is actually going to be the radius of a circle. So here I'm just going to write r equals 4, because again, we're going to rotate that shape around a central axis. So here in the side, we're going to sort of chunk this into pieces. Find the area of just the base. Well, we just figured out the base, the area of the base is just a circle, pi r squared. And the radius we already figured out is 4. So that's going to be pi times 4 squared. So that's going to be 16 pi. Okay. Find the lateral area. Again, no base is included. The lateral area of the cylinder. Well, the cylinder is the base of it is a circle, so we need to do the 2 pi r. That will give us the circumference of our circle, and then we will multiply that by the height of our cylinder, and here our height is 80. So height. So our height is 80, and we're going to multiply that by 2 and pi, and our radius is 4. 80 times 2 times pi times 4, that is 640 pies. Now for part C, the lateral area of a cone, I'm going to sort of draw a zoom in here. You know, up at the top, it looks like this. And then, of course, we rotated it, so we do have a cone. And our radius, we figured out at the very beginning, down here at the bottom is 4, so this radius will also be 4. Now we need the height of this cone in the middle. The overall height is 92. The other height is 80, so we're going to subtract that, and that's going to leave us a 12. 12. So we do have a right triangle, and we need to find the hypotenuse C. So I'm going to come down here in the corner, and we're going to do 4 squared plus 12 squared equals C squared. And that is 16 plus 144 is C squared. and those two numbers add up to 160 is c squared. So c is the root of 160, and it's not 40. I don't know what I was thinking. The root of 160. So our lateral area of the cone is pi RL. Pi is just pi. Our radius is 4. And then our L value we just found as root 160. And we're going to add all of these together. So I've got my 16 from part A, 16 pi. And then I've got my 640 pi from part B. And then I've got here 4 pi times the root of 160. So let's see, I'm just going to plug all those into my calculator as we go along. Total surface area of the crayon, 2,219.84, and our units would be millimeters squared. So there's our last example for today. For the practice, we've got one part AB and CD, and that's it. So pause the video, try these out, and then start it back up, see if you got them right. So in the first one, number 1, we've got everything handed to us on a silver platter. R is 12, L is 16. We are ready to go. Surface area equals pi r squared plus pi RL. Pi is just pi. R is 12, so this is going to be a 12 squared, or 144, plus pi times 12 times 16. So the first term is our 144 pi. 12 times 16 is 192 pi. So if we add that together, we get 336 pi as our surface area. But the directions here do say round to the nearest tenth. So let's round that off, use the pi key on our calculator. We get about 1,055.6 centimeters squared. That wasn't so bad. Let's see, in part B, they also give us everything we need. And notice here, we have two cones stuck together. So the base of each cone is stuck to the other base, so those will not be counted as surface area. So again, I'm going to sort of color code this. Here's our cone in red, and that is just going to be pi RL. Pi is just pi. The radius here is 5, and L was given to us as 20. Now we're going to add to that. I'm going to switch to blue ink. We've got another cone here. So that's going to be another pi RL. The pi is the same, it always is. The radius here is the same because the cones are stuck together. But now our L here is 9. So 5 times 20, that's 100 pi's. 5 times 9 is 45, and we got a pi attached to that. And if we add those together, the exact area is 145 pi. But again, we are going to round to the 10th if necessary. 145 times the beautiful number pi is approximately 455.5. Units are inches, and we're going to square them. All right. In my opinion, part C here might be the trickiest of these three. I'm going to sort of draw a little net over here. The bottom of this shape is just a circle. So we're going to have a circle plus. And then we're going to have the lateral edge of this cylinder. And that lateral edge will be circumference 2 pi r. And we'll multiply that by the height of that cylinder. And then finally, on top, we're going to have that cone. And the cone, we just want the lateral edge of that, so that's just going to be pi RL. All right, so let's see how much trouble this is going to be. Surface area equals, let's start with the easy stuff. Our circle, our area on the bottom, is going to be pi r squared. So that's going to be pi. Our radius is half of this diameter, so that's going to be pi times 2 squared. Plus, now we're on to this middle piece, the lateral edge of that cylinder in there. So we're going to have 2 times pi. Radius is 2. Height of that cylinder is 5. 5. Plus, we need pi RL for the cone on top. Well, pi's easy. The radius is the same it is on the bottom. That's 2. Now we got to figure out L. L will be this. Let me switch to red ink. We want to find this part of that cone that I'm hitting in red. And if we drop this dotted line down here, that will be the height of the cone. That's something we can figure out. Overall height is 8. Height of the cylinder is 5. So if we subtract, that is 3. And then our radius here at the bottom of that cone, here on the circle, that's going to be half of this diameter, 4. So that's also 2. So if I come over here and draw a little cross section, this side is 3, this side is 2. We want the hypotenuse. So a squared will be 3 squared, plus b squared, that's 2 squared, is equal to c squared. So 9 plus 4 add up to 13 is c squared. So c is root 13. So that is the lateral L for our cone on top, root 13. So let's see here. 2 squared is 4. We've got a 4 pi. Plus 2 times 5 is 10. Times this 2 is 20. So that's going to be a 20 pi. Plus 2 root 13 pi. So if we can just do these in our calculators one at a time, we will see our surface area of this weird shape is about 98.1. Units are centimeters squared. All right. One more practice problem to go. Let me slide this over here so I have more room. So this is just a basic cone. So it's going to be the surface area formula we saw way back at the beginning, pi r squared plus pi r L. All right, if we look at our base here, we have the diameter is 18. Half of that is 9. So our area of the base is going to be pi times 9 squared plus, now here's our lateral area, pi times r. R is still 9. But now we need L. So back to the picture, L will be this distance here. And if I bring it over here, we have a right triangle. So this side here on the bottom is going to be 9 squared plus our height is 40, and we'll square it. And that's going to equal our hypotenuse, or c squared. So 9 squared is 81. 40 squared is 1600. Those are going to add up to 1681 is c squared. And if we hit the root button, it turns out to be a beautiful 41. L is 41. So this L right here, we're going to multiply that by 41. So let's see, 9 squared, that's 81, and we got a pi. Plus 9 times 41 is 369 pies. And if we add those together, we get 450 pi inches squared. And if we use our pi key on the calculator, we get 1,413.7 inches squared. All right. That's the end of the problems. That's the end of the video. I hope you found it helpful.